Hello everyone and welcome back. So in this video we'll be creating step by step this liquid spiral. It will be a fun little experiment to starting to get used to DOP networks, and in this case we'll use POP network, and maybe you will be able to learn something along the way. So yeah, let's get into it. So we will start in SOPs by creating a geo container and creating a line. And we want this line along the x-axis, and we also want it in the center, so for that we can take the length and paste it in the origin, divide it by 2 and place it in the negative, so something like this. We want a length of 1 and 2 points, that's fine. Now we will resample it, so let's go with a resample, and point 1 will be fine. Let me see, yeah, point 1. And now we will create a mountain just to distort a bit the line, to give it some initial shape. And in this case, we don't want noise along vector. We want 0 centered, an amplitude of 0.2. I'm going to follow some values, but feel free to use your own. An element size of 0.48 and an offset of 20.7. So I guess this is fine. Hybrid terrain. Let me see if I change something in here. I don't think so. Yeah, that's fine. Now we will resample it again, so we can have a subdivided curve. So resample and go with subdivision curves and a length of 0.01. So we get something like this as an initial shape. Now we want to create a UV texture to have a U attribute. So in this case we want arc length spline. So we get something like this. The UVs along the curve. It's just like a curve view. Now we want to rotate this to create a spiral, and I will be using Vex, but maybe you can get away by using the sweep SOP. But just to be fancy, I'm gonna use some Vex, and maybe you can learn a thing or two. So first of all, I'm gonna drop an orient along curve to create the first vectors, and we will create on the x-axis the tangent V, and on this tangent we will create the tangent U. Let's check out those vectors. So tangent U will be along the tangent, and we will also have the tangent V, which will be pointing in outwards, as you can see by the x-axis. All right, let's get into the Vex part. All right, let's drop down an attribute wrangle. And this might be a bit intimidating, but you'll get used to it, I guess. So let's create a float U, and this will be equal to our U component of the UV, in this case X component, and we will multiply it by a channel so we can repeat the revolutions. In this case, a mult. Let's create that parameter. In this case, I'm gonna set it to 3 for now. Next, we will normalize our vectors. So vector tan U will be equals to normalize, just in case. The vector at tan U, oops. And we will also normalize the tangent V. So tangent V, and let me get this out, and V. Now we will create a full revolution. For that, we will multiply the U by pi times 2, which is equal to 1 revolution, but then we will repeat it 3 times. Next, we will create the quaternion. So in this case, I'm going to use quaternions. You can use matrices, but I'm just more used to quaternions. So vector 4, I'm going to call it quad, and it will be a quaternion. And the angle in this case will be the U, and along the tangent U. Next, we will rotate. So tangent V will be equals to Q rotate. I don't know how to say. Q rotate, that's it. And then we will rotate the quaternion along the tangent V. And let's see if we have any errors. No, let me just get rid of the visualization. And now we can assign to the position plus equal to tangent V, and we will multiply it by an amplitude so we can control the amount. In this case, I'm gonna call it amp. Let's see how that goes. And we will go with a value of 0.029. In this case, it's not doing much, is it? Because I've done something wrong. So normalize tangent V, mult U by times 2, vector quad, quaternion U, tangent V, Q rotate the quaternion around tangent V, tangent V amp. So why this is not working? I believe I know why, because we need to set this to point. Yeah, that was the problem. So the amount of revolutions, as long as you have enough points, in this case I want 3, and the amount you want to displace, in this case 0.029. So make sure you have this on point, because we are running this over points. And now we can just create the up attribute for the sweep. So V at up, it will be equals to normalize the tangent V. And I believe that will work. Let me check. So let me reduce the size, and we will have the spiral effect. And now if we sweep this, so in this case we want to set it to ribbon, and I believe that's all. Let me see how much I used, a width of 0.09. So then you have this spiral effect. So let's drop down a normal just in case and create a null called out spiral. And next we will drop a pop network. And let's dive into it. Let me just check what am I doing in here. In this case it will be pretty simple. Let's make sure in the source we are using use first context geometry, so that's fine. On the bird we will emit 5,000 points and just a life expectancy of just one second. And let's interpolate the source forward to get rid of some jittering. And other than that, I can just set the inert velocity to 0, but I don't have any velocity. That's just fine. So 5,000 points, let's see how that looks. It's just creating the points, and after 1 second they will disappear. Let me just check this and set it to 120. This will be more than enough. Make sure we are on real time playback. And now we want to create some pop force in here. So pop force to create some more interesting shapes. And in this case, I'm gonna use an amplitude of 0.45. This is just the amplitude of the effect, and a swirl size of 0.3. And I also played with the offset of 50. You can follow these values or introduce your own, but now if I play, you see the points will go in all the directions because of this noise effect that we have in the pop force. So we want to constrain it not totally, but partially along this initial shape, this spiral we have in here, and also make it flow along the shape. So for that we will need a bit of vex, so let's create a pop wrangle. And the first thing you want to set up are the inputs. So in this case, I'm gonna go to the inputs, set this to myself, and the second one to a sub, and let's target the spiral. Let's go to the codes, and we will use the min position to attract the points to the surface. So let's create a vector min pos will be equal to min pos. Oops, vector mp it will be equal to min pos of the first input and the P. And now we will create the direction force. So vector there, it will be equal to normalize min pos minus the current position. And we will also multiply it by, let's just call it min pos. It's not a good name, but it will be easier to understand. And let's create that. Let's multiply, let's keep it at 1 for now, and let's see. So for some reason, oh, of course we need to apply the force. So V at force, it will be equal to there. And let's see now. You can see it's constraining for the most part to the geometry. If we don't do that, it will be all wild. Let me just check if I increase this. It will be even faster, but we don't want that. In this case, we want a force of 0.349. Let's see how that goes. Yeah, that's fine. Now we also, this is not really necessary, but I want the points to be flowing around the spiral. So for that, I'm gonna create a vector tan u. It will be equal to v at tan u, that attribute we had from before, and we will, and we will multiply it by, again, a multiplier. So let's just call it mult, and let's create the parameter. In this case, I want 0.02, and now we can just add this. So plus tan u, tan u. And let's see. Let's decrease this, let's disable this, and you'll see they are moving along, and I can increase the velocity, the force I mean. So in this case I want just a small value. As you can see, they are moving. This is more like if you want to create an animation. In this case I'm going to use a still frame, but you can create an animation from this. So I believe that's all, and now we will introduce the pop force, of course. And let's see the result. And now we want to create some tendrils to create that liquid effect. So for that, we're going to use the pop fluid. And I have some values from before. So let me just check. In this case, I want a particle separation of 0.01. Let's see how that goes. So it starts to create these clusters of points. And let's increase the constraint iterations and the stiffness. To have a more stable simulation, we can reduce the tensile radius and maybe increase the viscosity to 0.2. So let's check how that looks. And we start to get this liquid effect, which is pretty cool in my opinion. But I'm just starting to learn more about these simulation nodes. I've been exploring almost exclusively the SOP operators and Solaris, so I'm a bit behind on the simulation nodes. So yeah, that's done. Now what we will do, we will time shift a frame that I liked, and hopefully it will look similar. Otherwise I'm gonna be playing with the frame in here. So 53, let me see just to check if that is what I had in mind. So I guess that's different. Let me see. Why is that different? Let me check the spiral. Let me see in this sweep. 0.09. I have a different spiral. So in this case, on the sweep, I applied some scale along the curve. Let me just check. And I have a value of 0.333. So this is more like it. Let me just check. Let me play back this again. So do I have a reset simulation in here? So let me just try this. Let me simulate this again. And time shift the frame. 53 in this case is correct. And I get a similar enough result. It's pretty similar in this case. It's not the same though, I don't know why. Let me just check if I have something in here different. So 5001 forwards, and let me see the pop fluids. I might have something different, 0.2, 0.01. No, it's basically the same. But you know what? Let's keep it like that. An amplitude 0.3, 0.5. That is fine, I guess. I wonder why this is a bit different. But I guess this will do. Let's see, let's mesh it and see how that goes. So we will use, let's see, that's fine. And we will use a particle fluid surface. Oops, particle fluid surface. And let's go with a particle separation of 0.003. And the result is not bad. And the rest is fine. And we will convert this. So convert to polygons, because this is a polysoup, I believe. Polysoup, yes, whatever that means. And we will also file cache it, so file cache. And that's our liquid line created. So let's create a null and call it out fluid. And right now you're probably tired of listening to this ramble, but I'm gonna continue on, and if you want to learn a bit more, stay with me, because I'm gonna create some art shapes, chocolate like. So let's create a super formula shape, which is where we have an art. So super formula shapes, and we will create an art. Let's go. We have quite a few in here if you want to play with shapes. So art, and we will use a width of 1.1 in this case, and we will resample because it's too much. 0.08 is fine. Now we will thicken this to create the extrusion, and in this case we will do both directions and 1.5. Let's get rid of the UVs, and maybe let's keep it like that. Now polyfill, and I believe I used just single polygon, so let's just not get into trouble. And reverse, and probably can apply some normals. I didn't do that, but just will be easier to visualize. Now we want to create this balloon-like art, so we can play with the sculpting tools, but I'm not very good with sculpting, I admit. And so I'm gonna use instead Vellum. So for that I'm gonna remesh to have a nice topology for Vellum. And in this case a target size of 0.08. Let's blur it a bit, so attribute blur. And we will blur it. 1 is fine. Now let's create a Vellum configure balloon. Let's see, and a Vellum solver. Let's press J and drag. Let's see if this doesn't take ages to compile. And reduce, just remove the gravity. We don't need that. And let's see how that goes. So it doesn't move. Let's go to the Vellum pressure and set a rest length of 3 to increase. And now it will rotate around. It's creating the ideal shape. In this case, I believe I played with the Vellum cloth in the stretch. Did I? Yeah, I don't think so. Let me just check. And why is this so slow? Okay. In this case, I didn't play with this, so that's fine. Now we need to make this static. So for that, I'm going to create a Vellum constraint. And in this case, set it to pin to targets. No, it's too fast, dear God. And we're gonna set it to soft so it can still deform, but we want let's set the stiffness to 1 in this case. Let's see if that helps, and it does. It just rotates a little bit, so that's fine. Let's maybe time shift, and in this case I'm gonna time shift to frame 60, which is fine, and we have this nice arch. Let's create a Vellum post process. So Vellum post process, and I'm gonna blur it by 0.146 and give it a subdivision. In this case, look, because we are working with triangles. Let's see if that gives us a nice shape, I guess. And now you can keep it like this. In this case, I'm gonna quad remesh it. So in this case, I have the exercise quad remesher, which I recommend. Now it was too much. I just want 500. I want to mirror on the X and on the Z. I believe that's what I did. Then I'm gonna just freeze this so you can have access to it on my Patreon files. And I'm gonna subdivide it just once. And now the roster doesn't stop, dear Lord. Sorry about that. And the next part, we will create some liquid forming on top of it. So now let's create some decorations on top of this art. What the heck? So just on this one, let's create a draw curve, which is the simplest way of doing this instead of trying to do this with some vex or something like that. So let's press enter, and in this case I'm just gonna do it freestyle, maybe try another one. Oops, now I'm getting too sloppy. So something like this will be fine. Let's save it, and in this case I'm gonna resample it, and we will resample by 0.05 and set to subdivision curves and do another bigger resample. So let's copy this and do 0.01. That's fine. Let's maybe move this on the z-axis. So let's move this by 1, and we'll ray over this geometry. Minimum position will be fine. Let's just make sure we output the heat prim, and we will blast. And we will blast at heat prim equals to -1. So the ones that didn't eat, so caps lock heat prim. So that's fine. And now we will resample it again. In this case, quite a bit, I guess. So 0.01 and set it to subdivision. That is fine. And let's create an attribute to just float for the p scale. Let's just set this to 1, to some value, I mean. And let's create a sweep and see what we got. So rounded tube, and we want, in this case, let's see, let's reduce it quite a bit. And also we want to create an end cap of grid to create this rounded shape. And now we want to play with the p scale. In this case, I'm gonna set it to noise to create some irregularities, and a mean value of 0.18. And I'm gonna play with the element size, maybe not so much, and the offset. Let me find a good value. So something like this. Let me just play a bit more. Yeah, this is fine. And next, we can create a name. And what did I call this? Liquid art. Art liquid. And let's name this art shape, and merge these two with alt and create a null. Let me just check. I have so many attributes, so we will attribute delete after it. So let's get this and create a subnet, and this will calculate again, unfortunately. Oh, that's fine. Call it art. That's fine. Let me get back to my file. And let's see. Let's get these into here. And we will create a normal, because we will scatter some points on this liquid line. So on the points, and also scatter. And in this case, I'm gonna scatter 8 points. I use this seed, but probably you will have to change it. That's fine. Let's see if we have the normals. Yes, let's pick it a little bit so the arts are a bit offsetted from the liquid shape. Just a small distance of 0.004. We will make sure to delete any attributes. In this case, we can just delete all. So we have many, so let's just delete all. And attribute adjust float for the scale. And let's first of all copy it. So copy the points, copy these out to here. And the scale will be too much. So first of all, we can create this random and between 0.65 and 1, seed of 50, something like this. Create another scale. In this case, I'm gonna set it to constant and multiply, so we can control the overall, the global effect. So in this case, 0.05 would be fine. And we will also create an attribute randomize. In this case, we will randomize the orient and direction and orientation for, and play with the seed around to really get something decent. Let's maybe let's organize these and create a merge and merge these two streams. Let's maybe play with the orientation and play with the scatter seed. Guess this will be fine, nothing too much. And now we need to create a name also for the splash. So name, let's call it splash. And now we just need to delete some attributes. In this case, we just want to keep the name, so attribute delete. We will delete all but the name. And create a null. And set it to out, Solaris. Let's check just the name attributes, and we indeed have a unique name for every piece. Now let's move into Solaris. Okay, let's move into Solaris then, and let's change our desktop and create a sub import. Let's merge it and import the out Solaris. Let's zoom into it. Oops, H is orienting properly. Yeah. So we will need a material library to create our materials. This will be a really simple setup, but while we're here, we will create some rendering some materials and make a picture out of it. Let's set it to flat and I have an HDR7 HDRI or polyheaven, I should say. And I will include this on the final file. And let me create a camera from here. So let's create just a camera. This is fine. Let's lock it and make sure we're rendering the viewport size, background, dark, that's fine. And we have the camera. Now let's create the render settings and the render up. Let's change it to XPU. 512 is fine. And we will use SSS so we can increase the limit quite a bit. Let's see how that looks. The dome light, everything is working. Let's see. So that is fine. Let's get rid of the grid. And let's create the materials. So the first material will be the liquid. So let's create the karma material. Let's call it splash matte. Oops. Splash matte. What the hell? Splash matte. And let's see. We don't want any diffuse. Specular, we want a value around 0.43. And we also want some coat around 0.45. Roughness of 0.1 is fine. Let's increase the subsurface. Connect the color to the radius and a scale in this case of really small, in this case of 0.0002. And we want a color something like this, a light gray. We can get rid of this. Let's see if that works for us. So let's assign this to the splash. Oops. And let's see how that looks. Am I using the correct? I'm not seeing. So the material is fine. And the dome light. Light long, empty room. Why is it looking so different? Let me just check. Am I applying the correct material? Sorry, I was looking at the wrong material. Let's just make sure we have a scale of 0.005 to have a more subsurface look. And in this case, I don't want any coat. I just want a specular of 0.25. And let's see how that looks now. And that starts to look like the liquid I want. We can maybe play a bit with the rotation. Let's see. Let's go with the rotation Y. In this case, it wouldn't help too much. Let's leave it like that and create the remaining materials. In this case, we will duplicate this one and create a Choco Art matte. And now let's see, we will maybe play with the roughness and add some coat. So in this case 0.45, roughness of 0.1. And for the subsurface I have some color in here. I'm gonna use this value, you can copy if you want. And as the depth 0.001. Let's assign it to the art shape. And let's see how that looks. That is fine. And let's just create the last one. In this case, Choco Liquid Matte. And we will leave the specular as it is and just change the subsurface. In this case, we will set it to this value. So let's apply it to the art liquid. And let's see how that looks. Let's save and render. And we can possibly apply some denoiser. Let's see how that looks. And yeah, that starts to look a little bit better. And that's really fast, so we're not wasting too much time in here. So yeah guys, a very simple tutorial, but I hope that you have learned a thing or two. It's just making something really simple a bit complex, which doesn't make much sense, but you know, in the end of the day you might learn a thing or two. So if you want, you can grab this in on my Patreon alongside with hundreds of project files, exclusive tutorials, hours of exclusive tutorials, really in-depth, step-by-step. And I also have some cheap courses on there, but in my opinion, have a good quality. So if you want to check that out, make sure to see my shop on Patreon. So, other than that, thank you for watching, and I'll see you next time.